My name is Ranger Tom Randolph, and I am coming to you live in video, I guess, from Mount Jefferson State Natural Area. Where is Mount Jefferson? Our park here is just, or I should say your park, because this is public lands, it belongs to everybody. This park is close to the state of Virginia, to the north of us, the state of Tennessee to the west of us, and we're here in North Carolina, in Ashe County, North Carolina. I am really looking forward to the day when I can come down and experience the Lumbee River and learn more about the water down there in the area that you're in, where this video is being shown right now. But today, I thought I'd take you on a hike and share with you a little bit about Mount Jefferson, and also share with you just a little bit about what I've learned about the park. Part of this program is this month is Native American Heritage Month, and I would like to share with you some writings that I've read, some indigenous writers. For the last year, I've been studying indigenous ways of knowing at the University of Idaho when I'm not working as a park ranger. And so I have been working with different professors, Dr. Begay, who is a Navajo professor, Dr. Anthony Stevens, and she is Apache. And I've been reading lots and lots of indigenous writers, writers from all over the country, including a writer from the Lumbee tribe, Dr. Brayboy. And Dr. Brayboy writes about critical tribal race theory, which is really guiding a lot of what I'm doing in school. So let's start off with a couple of readings that talk about nature. This one right here is from Land Education, and it says, colonial perspectives often see land as a commodity, as something to control, something to own and exploit for the colonizer's benefit. Dolores Calderon writes, all places were once indigenous land and continue to be. Dr. Calderon also writes, changes do not sever the relationship that indigenous groups have with the land, that relationship with the land. And Quangley writes, often said Mother Nature has a culture, and its culture is native culture. So as we go up on Mount Jefferson, I myself, I am not a tribal person. I'm still kind of trying to find more about my ancestry and my history, but I will share with you what I've been able to learn over the last year and a little bit about the park and the mountain. We're also going to talk today about career opportunities. Some of you might be interested in working outdoors, might be interested in working with soil, water, and conservation, or maybe becoming a park ranger. So we'll talk about those career possibilities too. So right behind me is a plaque that talks about Mount Jefferson. What's really special about this park is researchers have found that there are a lot of plants up here. There are over 750 different kinds of plants, and that's why it's a National Natural Landmark. The Lumbee River is a National Scenic River, and like I said, I'm really looking forward to getting out there and seeing that river and learning about the plants that are out there. I guess we ought to go ahead and hike up on the mountain. I don't want to spend too much time here in the shelter. So we're going to go up on the trail and get to know Mount Jefferson. Right behind me is a rock called amphibolite. That's the main rock that's up here. Now down on the Lumbee River, there are going to be totally different types of rock, different types of geology. But the same kinds of forces are really at work. I like to think of, a naturalist going from one place to another. It's kind of like a kaleidoscope. All those little pieces of glass that have different shapes and colors, when you turn them around, when you go to a different place, you're seeing the same kinds of things, but they're in a different place. So I would strongly encourage that you get to know your place, your area. Hopefully you've been swimming in the river there or done some fishing in the river. Up here we don't have any river. We've got this rock, and it's kind of chilly today. It's going to probably be in the 20s tonight. So this rock is called amphibolite. It's been up here for about 300 million years. So before the dinosaurs came on the earth, these rocks have been here. Now this mountain at one time was probably about 20,000 feet high, but some forces known as weathering and erosion have really broken this mountain down. Weathering up here is caused mainly by physical processes. Physically, what happens, just like if you leave an ice or a can of soda in your freezer, if you leave it in the freezer, the can is going to explode because the
liquid inside the can will expand, the water, it will expand and it will bust the can. Up here in the mountains, we like to leave our water running in the bathrooms sometimes in cold nights so the water doesn't freeze and bust the pipes. Well, the same thing up here with these rocks. For the last 300 million years, cold temperatures like today will drop the temperature of the water that's maybe seeped into these rocks in the form of rain or snow. Then, let's see if I can get up here. Then that water will freeze and expand and make a crack. And these cracks will get bigger and bigger and bigger and break the rock down into smaller pieces. Eventually, those pieces of rock will get so small, they won't even be called rock anymore. They'll be called soil. And that limit is once they reach about 2 millimeters in size, that's the size of a sand particle of soil. And basically we have sand, silt, and clay as the 3 particle sizes. So the rock, the parent material, is broken down through weathering, and then it starts to turn into soil. The other process, which starts with an E like the word exit, is called erosion. We'll go up here and find out what erosion is. All right, we are looking at some more amphibolite, and I thought I would do another reading. My daughter Aurora is actually filming, so she's going to pan around at the rock, and I'm going to read a little more from Linda Smith about indigenous ways of knowing. And she says about indigenous people having a spiritual relationship to the universe and the landscape and to the stones, the rocks, the insects, and other things seen and unseen. This has been difficult arguments for Western systems of knowledge to deal with or accept. These arguments give partial indication of a different worldview and alternative ways of coming to know. And one of the clearest ways I see that is in our management of fire, and how indigenous people have been managing fire for thousands of years in North America. And it wasn't until just recently that we've started to have controlled burns and started to maybe take the example, definitely take the example and take the lessons of indigenous people regarding how to manage fire. We might talk about that later, but I wanted to kind of talk about erosion, get back to erosion. I don't want to go off track on the erosion part of it. So erosion, again, is after the rock has been broken down through physical weathering, those pieces like this can get blown away, and I'll show you right here. They're blown away because they're so small. If it's this big, it's not going to go anywhere. So the weathering breaks the rock down, and then erosion is what carries it away. And you can have water erosion like the Lumbee River carrying away, eroding away the rock. Up here, right now, we have wind, and that wind is causing erosion as well. It's blowing these bits of soil off into the air. But first the rock was broken down through physical weathering, and now the mountain is only about 4,683 feet high. So the mountain's been broken down through physical weathering, and then erosion is what's carrying the sand, silt, and clay, the 3 particle sizes of soil, away. And this also reminds me of another part of indigenous knowledge. Dr. Little Bear talks about, he's got a great YouTube video, and he talks about quantum mechanics and some of our understanding in Western science versus indigenous ways of knowing. And one of the things I've read was about stories about plants being able to talk to each other. And some Western perspectives might say, well, wait a minute, plants don't talk to each other like maybe this moss or this grass. Well, now the Western science is starting to realize, yeah, they do communicate with each other. Through chemical processes, these plants actually do communicate with one another. So slowly but surely, it seems to me that Western knowledge is starting to realize the vast amount of indigenous knowledge that's existed in North America. On this mountain alone, we know that people were here 8,000 years ago. And by reading Melinda Lowry's work, she's a Lumbee tribal member, has written some amazing books, she mentions people being in the Lumbee area there for up to more than 13,000 years ago. 13,000 years ago, where you're at the high school right now, there may have been people wandering around right there, living on the land and experiencing the sun and the earth just as you do. But it was 13,000 years ago. All right, well, we're going to go up and take a look at maybe one of the sites, a place where people in the mountains would take shelter, different types of geology, and then we're going to take a look at some of the views and maybe talk a little about climate change too. So we've talked about erosion, carrying the rock away, weathering, breaking the rock down, the soil sizes, sand, silt, and clay, the particle sizes. Let's head on up the mountain. Another author that I've been reading, Kortweg, their writing says that land extends beyond material fixed space. Land extends beyond material fixed space. Land is a spiritually infused place, grounded in interconnected and interdependent relationships. This indigenous writer really captures that idea of interconnectedness. And that's truly, as a park ranger, what I see when I see the sun shining 93 million miles away. And, you know, I can think about the Western perspective, think about, again, Dr. Little Bear talks about quantum mechanics and how Heisenberg's uncertainty principle kind of throws a lot of our Western perspectives that science can know everything right out the window, because quantum mechanics shows that things are uncertain. There's probability. There's a lot more of a flux. And that's what Dr. Little Bear talks about, is flux. And when I think about the sun's energy, fusion, those atoms of hydrogen being converted through fusion into helium. Hydrogen has one proton in its nucleus. Helium has two. They're combined together. And that energy being released to all these plants around us, and also that energy interacting with the atmosphere of the Earth, and the tilt of our Earth, giving us our climate and our temperatures. So right behind me, we'll take a look around, is an alcove. This is an excellent shelter for up here in the mountains. And again, from what I've been able to find is people have been up here since at least 8,000 years ago. They were probably here a lot longer than that. This rock again is mainly amphibolite, and from a geologic standpoint, amphibolite is a fairly hard rock. This is about a 5 on the mole's hardness scale. And remember, the mole's hardness scale measures from 1, which is talc, a very soft, to the hardest, which is a diamond, which is 10. So there's another major rock that's on this mountain that keeps this mountain resistant to weathering and resistant to erosion. It's not the amphibolite, because it's only a 5. It's this rock over here. Maybe we could take a look at it. This stuff here, that's called quartz. And quartz is about a 7 on the mole's hardness scale, much closer to a diamond. And this resistant rock is what's keeping this mountain standing so solid. And it also provides these amazing shelters. What a great place to have as a shelter. My daughter and I have used this for shelters for probably the last 15 years from time to time. Coming up here to watch certain events, like maybe an eclipse or a lunar rise in the distance, and it's a great place to get out of the wind. So I mentioned climate, and we're going to go up next and look at one of the North Carolina climate towers. I bet you there's a climate tower somewhere close to your school as well. You could go to the North Carolina Climate Office website and maybe find the map, and I bet you can find the climate tower that's close to you. But let's go up on top and see what we have up here at the summit of Mount Jefferson. It's a little chilly up here on the top of the mountain today. So a quick reading from from Megan Bang, and she writes, learning about the natural world is a critical necessity given the social scientific realities such as climate change. So while the wind is blowing, let's go ahead and look at our climate tower, and you go right up to it and get a good, so that's the North Carolina Climate Office if you want to find the tower closest to you near the Lummi River. If we go all the way to the top, we can see these things spinning around. Those are anemometers, and they are picking up the wind speed. These gauges right here are picking up the air pressure, right over here and here. These two sensors are picking up the sun's light, not just the sun's energy, but also the type of light that's used for plants. Over here is a rain gauge. It picks up the amount of water that comes down in the form of precipitation and includes snow. It melts, gets measured, and then it comes out down through here through a little hole. Now all this information is being stored in this box, and then it's being sent down to the North Carolina Climate Office. And what we're trying to do, and what they're trying to do, is to get an idea of what is the trend of climate. I know a lot of people are always thinking about the stock market. You know, the stock market goes up and down, but we like to think that it's actually kind of going up, at least, you know, well, we're kind of thinking about the 401k of climate here, the long-term look. Not just like today, it's really, really cold, but if we look at these temperatures over years and years, we'll start to notice there's a pattern, and that pattern is showing us a trend toward much warmer climates, much warmer temperatures. And this is caused by humans releasing rock, the rock, basically the coal and oil, these fossil fuels that have been sequestered, trapped underneath the earth for a long, long time, and now we're releasing that into the atmosphere, which is causing a greenhouse effect, causing the climate to change, and it's also creating feedback loops. So we've kind of come to the top of the mountain now. We're talking about climate change. Why don't we go down to the river, the New River, which flows north, and take a look at pH and some of the other qualities of the river. All right, let's go. So we are at the New River. That's the river that's out here behind me. And I thought I would just do a little, again, another reading real quick. This statement talks about each unique location provides meaning in land-based on tribal history, ancient knowledge, and experience. This means there is no one indigenous religion that explains the belief or creed of every tribe. Tribal people continue to practice traditional, spiritual ceremonies that relate to the environmental stewardship. Some tribal religions share certain universal values regarding sustainability. For example, many tribe precepts value the protection of future generations and community over immediate short-term gain. The 7 generations perspective is not seen as a commandment, but more like a good, responsible way of doing things. And when I first read about the 7 generations idea is when there was some oil exploitation that was going to happen up in northern Canada, and the chief there had a dream about the environment being damaged there from that oil exploitation. And that kind of goes back to the idea of protecting not just for the short-term gain, and this is why they didn't allow that oil exploitation to happen, was because they knew that generations, the next generation, the next generation, the next generation would suffer from the decisions that were being made in the present. And that also that reminds me of the pipeline that was going to go through from Pennsylvania down through West Virginia, into Virginia, and then down into North Carolina and down into the Lummi tribal area, which I'm so glad to say has been canceled, because that would have impacted a lot of different areas of water quality, air quality, climate change because of methane that's released from those pipelines. from that particular type of pipeline with the natural gas. So part of a job, I think, of a resource manager, and if you're thinking about a career, is to monitor the water. And we're going to do that in just a second, but I wanted to share with you about one of the interconnections that's here. This is a tree, and as you can see, it's been chewed on. So this tree is the result of photosynthesis, and the sun's light has allowed this thing to grow. The beaver come along. This is a beaver skull, and basically eat this plant. The energy then goes from the plant to the plant eater, and then ultimately it will go to the meat eater. It's this coyote that lives up here in the mountains, and the coyote then eats the plant eater, and the energy is then passed from one animal to the next. And this is the pelt of a beaver. This is an animal we see out here. We saw a huge one out here not too long ago. This I purchased from Pennsylvania. This was not something we hunted here in the park. So there is no hunting allowed in the park. So looking at water quality, let's see if we can do a sample here. And we're going to use this pH kit to look at water quality. Okay, so what I'm going to do, we're going to just look at pH. And if you don't remember pH, what that is, that's just a scale that looks at acidity and base. So if a number is below 7, that's an acid. So like 6, 5, 4, 3, those are acids. Any number above 7 is a base. So that'd be up to 14. So 8, 9, 10, 11, 12. So we're going to find out what the pH of this river is. And you can do the same thing in the Lumbee River and check out the pH there. Now I'm going to bet that the Lumbee River is a little bit more acidic because it's so dark. And that dark water is because of natural tannic acids. And those natural tannins are really, really amazing. That's a part of a plant that makes that water so dark and gives it such a rich look. And I really do want to, I'm really looking forward to getting into the tannic acids and into the swamps and exploring. So here we go. Let's do our test. So we have our sample. This is river water, and I'm going to put the indicator in it, and it should turn a color when I do this. So let's see. All right. Put the lid on it and give it a little shake. We got a color. So now we match these colors up with this color. And I'm going to say, I've got a number in my mind. What do you think that is, Aurora?
6 or 6.5.
So a 6 or 6.5. So that tells us that this river does have a natural acidity to it. It is acidic right now. It's below 7. So, other areas that we look at with acidity might be in the rain and the precipitation. And, keep in mind, when we breathe out a gas, carbon dioxide. We breathe in oxygen from plants. We have that interrelationship always going on between plants and ourselves and animals. But when we burn fossil fuels, we're putting that CO2 into the air, which of course is adding to climate change. But CO2, if you take it, you could write this down, CO2, carbon dioxide, and then you add that to water, and that's including rain, precipitation, add that to H2O, you have H2O plus CO2. You put them together, that's H2CO3. And H2CO3 is carbonic acid. And acids like that, you can even get even more intense acids that form by other chemicals that are burned that get put into the atmosphere, and that causes acid rain. And that's something that can affect our land, the soil, the land here, the soil, and the water quality. So we have to look at both of those areas. And as a resource manager, you're going to get into the career of working and actually getting paid to be outside. You might want to know more about that whole process. So we're going to go inside for a few minutes and talk a little bit about careers And this is the new river, but I am so looking forward to getting out on the Lumbee River and also checking the pH and just seeing what that pH looks like there. So let's go inside.
Well, we're back inside, out of the wind. I wanted to talk a little bit about careers. And before I do, I'd like to kind of bring out the point of everybody that becomes a resource manager, a park ranger, or a soil water conservation, works for Audubon or Nature Conservancy or some other agency. They bring their experiences to the job. That's what makes someone that works outdoors makes them really love what they do. So you have experiences on the Lumber River. You have experiences in your part of the land that's there. You have stories that you've learned and heard in your community, in your tribe. You have dance and you have song. And all of those elements are a part of who you are. And don't really think about, well, what is this guy doing? What is his path? My path is my own path. What you get to do is bring who you are and all those stories and ideas and concepts and views of the world, bring those into the position that you decide to go in. If it's working for a state government, a national park service, some federal agency, some private non-governmental organization, who you are and how you feel about the river and how you feel about the land and how you feel about the ocean and the sky, that's what's really important. So don't think about it as, well, I've got to come in and you know, be like this guy who's in the video. Not at all. Who you are is what's important. That's the primary idea, is bringing who you are into the position. So we're going to dive into that in just a second, some of the career opportunities. I'd also like to do a quick reading again. This is a book that it's really caught my attention. I'm going to show you all the books here at the end. But this one, the reading talks about, from the time we're born, our stories intersect and connect with other stories as we walk the earth. The tracks of all our ancestors can be traced at varying levels, with the most recent ones most evident on and near the surface of the land. Buried deeply are the first tracks, those of indigenous people who have and continue to exist on the land since time immemorial. And one of the things that makes being a park ranger kind of fun is you quite often get to live in the park, and the park usually provides you with a residence. Career-wise, you know, if you work for the National Park Service, or if you work for North Carolina State Parks, or South Carolina State Parks, or Virginia State Parks, all 50 states have a state park system, and that includes Hawaii. There are also parks in the Samoas and in the Virgin Islands, and of course Hawaii and Alaska and the Arctic. So there's some pretty amazing places. If you're interested in working outdoors and getting some experiences, the parks are a great way to do that. But there are also other agencies like Soil, Water, and Conservation programs. There's the U.S. Forest Service, the Army Corps of Engineers. The Bureau of Indian Affairs does some resource protection programs on some of the reservations. There's also private organizations, like I mentioned earlier, well, I'll mention at the end of the movie, the Nature Conservancy, the NGOs, non-governmental organizations. The trick about getting one of these jobs is knowing when it's advertised, when does the job open, when can you apply to it, and when does it close. Because you can't, if you don't know about a job, then you can't apply to the job. And a lot of people just don't really realize how you go about doing this. So there are websites. It makes it a lot easier since there are those websites. USA Jobs is for federal positions, and that can mean anything from the Bureau of Reclamation, the BLM, the Bureau of Land Management, all the Department of Interior positions, U.S. Forest Service, Department of Agriculture, Even NOAA and the EPA has positions that you can get into. Again, the state parks, also the non-governmental organizations. Now, education-wise, they're all going to be different. Some park systems, like Florida state parks, you can get in with your high school diploma. I know of one ranger that got into North Carolina state parks with an associate's degree, but mostly they look for a bachelor's degree for North Carolina state parks, and that's because we do so many different things. We do law enforcement, resource protection. They train us on chainsaws. We're trained in search and rescue. We're trained for fire. We're trained for emergency when people get hurt in the park. And it's kind of a real variety. If you're interested in learning a variety of different skills, North Carolina State Parks is a great way to go. And from what I've experienced, along with other rangers, is that once you get your main parts of your job done during the day, you can pretty much focus on whatever you're really interested in. So if you're interested in fire, or if you're interested in plants, or if you're interested in studying bats, or if you're interested in fish, you can take those interests and just follow them, see where they lead as a part of your job. And that's the really cool thing too, is you get paid for it. So if you've ever wanted to go walking in the woods, you can do that, and I do it all the time when I'm not working. But I also get paid to walk in the woods. I get paid to inspect the trails, to make sure everybody is doing okay out in the woods when they're hiking around, to look at plants, to look at lichens, to inventory what's in the park. And one of the parks that's close to you is the Lumber River State Park. And I spoke with one of the rangers today, and they said they are interested in having volunteers help them out, of course, after the COVID issue is done. And their number is 910-628-4564. And you can check out all of North Carolina State Parks on ncparks.gov. Also, you can contact me, again, Tom Randolph, at Mount Jefferson State Natural Area at 336-246-9653. Again, 336-246-9653. So we can talk if you have any questions. Other career opportunities, ways to get into a career like this, or to try it, maybe just to sample it. You can work seasonally. Many rangers are working seasonally in the state parks. You can get a seasonal job in the Everglades. That's where I worked for a while. You could work in Utah, Colorado, Alaska for 6 months. They provide you housing. They give you a uniform, and you work and you talk to people. Whatever area you're interested in. If it's resource management, if it's fire, if it's working with the public, if it's environmental education. You could also get involved volunteering or interning with the Student Conservation Association. That's an agency that flies you to your location, pays you a stipend, and gives you housing. Also, AmeriCorps is a great program. I think my daughter's going to be getting into AmeriCorps. And with that, you go do some sort of service that's outdoors with usually a group of people. They train you. All of this involves training. You get trained no matter what you're going to do. So don't worry about that. And they pay you, and they give you money for college. That's AmeriCorps, another really great program. So there's lots of options, and I can certainly talk further and about this. And if you have questions, you can email me too at tom.randolph, R-A-N-D-O-L-P-H, at ncparks.gov. All right, so that's a little bit about some of the career ideas. I also wanted to kind of go back to our pH. We had gotten a pH sample, and there's the color. You can really see that a little bit better. It actually looks like it might have changed a little bit. But just to kind of give you an idea about pH, remember any number below 7 is an acid, any number above 7 is a base. And we got the number that we had for the river was about 6.5. So we figured that's pretty acidic, and we attributed that maybe to plants. Plants have natural acids in them. We also talked about carbon, CO2. So this is a little bit of vinegar here, and I'm going to put some vinegar into this vial. And as you can see, it didn't take long at all. It changed colors really rapidly. So the pH of this is just about off the chart. This is about a, let's see, about a 5, about a 4.5 on the pH scale. You can see it better that way. Hopefully we're not going to be seeing too much at that level in our water. I'd be really interested, because of the natural tannins, the tannic acid in the Lumber River, I'd really be interested in knowing what the pH is there. So this scale can change. This is I've got a little bit of baking soda I'm going to put in here, and we'll see what the pH of this changes. Now it's going to fizz because of the reaction. Hopefully it's not going to make a mess here. Yay. Alright. Hopefully. But as you can see now, the color has changed to more of a yellow, and that yellow color is closer to our 6, closer to maybe a 6. Still acidic, but not nearly as acidic as the other one was. So that's a little bit about pH. We're inside, out of the wind, it's a little easier to talk about this sort of stuff. So I'm going to set this aside and kind of think about pH a little as we talked about pH. The other thing I wanted to talk about, it was so windy up on top of Mount Jefferson today, was a little bit about wind and air pressure. And when you think about wind, what I like to think about is kind of going like from up high to down low. If you have a rock, it's going to roll downhill, goes from high to low. And that's the same thing with wind. Wind goes from high pressure to low pressure. So if you have an area where there's high pressure in one place and low pressure over here, then the wind is going to go from here to there. And the steeper the gradient between those pressures is going to determine how fast that wind is. So the wind is really powered by this gradient, this pressure change. And just to give you a quick example of that, here's a little experiment we can do. This is a bottle, it's got a balloon on the end of it, and I've got a little hole here. I'm going to try and suck the air out of this bottle and create low pressure. And because of that process, the pressure that's in this room right now should fill this balloon up and hold the balloon in the, or hold the air in the balloon, just because of the pressure gradient change. So here we go. Okay, that has a little hole. We've got a hole in the balloon. So let's try it again. Okay, so the air is in the balloon. You can see right in there, there's no knot holding the air in. There's the air. And that's because there's low pressure on the inside, higher pressure on the outside. When I let go of the hole, the pressure should equalize. The air will go back into the bottle, and now they're equalized. So again, that wind we had on the mountain today, that's from high pressure, or air going from high pressure to low pressure. All right, well, let's go back up on top of the mountain and see what's going on now that it's getting close to sunset. Well, this is the view from Sunset Overlook, and I am looking off now to the west. These mountains out here are pretty much protected. The one up here, this is a NGO, non-governmental organization called the Nature Conservancy, manages the bluff, and they'd be actually a really good outfit to work for. They have places all over the world that are protected. Patty Mountain right over here is a part of kind of the state protected land. There's game lands over here behind that one called Treetop. Way over here off in the distance is Grandfather Mountain, and that just recently became a state park. And the mountains up this way are way over here. That's all Tennessee, and then Virginia is off this way. So thank you so much for spending time with me today. I hope I get to meet y'all in person one day. Maybe I'll get to come and visit the school. Maybe we can go to the Lumbee River and look for macroinvertebrates, do that water quality testing. I hope you have a wonderful day, and thank you again. This is Tom Randolph. We'll talk with you next time.